This is Jack Jackson. In previous videos, we've looked at some examples of performing t-tests, and we've used some calculator technology to do that. And this one, I want to just give you an exercise and see if you can figure it out, and then you can come back and check your answer as we proceed with the video. So hopefully a fairly short video and a short example. So here's an example here. The psychological test is given to determine the psychological status of an individual. A subject with a score of 40 is considered normal. Higher scores indicate more psychological problems. So a group of 23 patients with mild head trauma were given this test, and the sample resulted in a mean score of 48.43 using this psychological test, and a standard deviation of 20.76. At a 5% significance level, is there enough evidence to say that patients with mild head trauma score higher on this psychological test, and of course then thus have some more psychological problems? All right, so go ahead and figure out what kind of test you're supposed to use. Check that your conditions are there. State the null and alternative hypothesis. Perform the test. Write out your conclusion. See if you can go ahead and do all those things. When you're satisfied you have it worked out, then come back to the video and you can check your answer. It's very important that you, at some point, that you actually do some of these guys on your own so that you get practice and then check your work as we go. So this is a good chance to do that. Press pause now. Okay, so the first thing we need to do is check the conditions and determine what kind of test we use. Notice that we're testing the mean of one sample against the hypothesized mean. The scores have a normal distribution. That was assumed. So the sample means are distributed normally regardless of the sample size. And actually, even if the test scores are not distributed normally, we didn't have to assume that. Once we had a sample size of 40, that was enough to make the sample means distributed fairly close to normal anyway. And the population standard deviation is unknown. Those three conditions tell us that we have a one-sample t-test. Furthermore, this is a right-tailed t-test because we're testing specifically for a higher score, not just a different score. And the null hypothesis is that these patients basically with head trauma are no different than any other people, and if so, they should have a mean of 40. So the null hypothesis is that mu equals 40. However, if this is a different subpopulation than all people, then we might have a higher score on this, and it's certainly our mean score of our sample, 48.43, was more than the hypothesized mean of 40. The question again becomes, is it enough to that this is most likely to occur because there's something different about these patients with head trauma, or is it just due to random variation anyway? So our alternative hypothesis is that mu is greater than 40, so it's a right-tailed test. Well, the calculator app will do this. Here I've done it with the TI-84. You could do the same thing on a TI-Nspire. Different statistical packages, or even you can make Excel do some of this stuff as well. So anyway, those different technologies will work this out, but I'm going to specifically show you a TI-84 here. So pull up your calculator app for the t-test on the TI-84. That's stat test 2 t-test. We're not given the actual 40 actual individual measurements, but rather the summary statistics. So we choose stats right here, and then mu naught is that's what we assume it is 40, which is what it should be if these guys are just like everybody else. But the x-bar of our sample was 48.43. Standard deviation for our sample is 20.76. N is 23. And we're specifically doing a right-tailed test, so mu is greater than mu naught is our alternative hypothesis. If we click calculate, we get the middle screen. If we click draw, we get the last screen. So if we click calculate, you got this here. It shows you the alternative hypothesis, mu is greater than 40. The test statistic, t star, was 1.9 something. The p-value is about 0.032. The x-bar value is 48.43. The S of x is 20.76, and N is 23. Those last numbers we just typed in. And it's just reminding us of that. But it computed the T and the P value for it, which is the new information. The T and the P value are also displayed on this last curve over here without remembering the other numbers, but it also graphs the t-distribution where with n minus 1 degrees of freedom, that is with 22 degrees of freedom, and it graphs the PDF for that distribution. And you see that the shaded region there is the probability P, the probability that we got a test statistic, a t star value of this level or more extreme, and more extreme in this case means to the right. And so that shaded region has an area of 0.0322, which is equivalent to the p-value. Now notice that p is less than alpha, 0.032 is less than 0.05. So at the 5% significance level, we see that there is sufficient evidence to conclude that the patients with mild head trauma have more psychological problems than normal as measured by this test.